Okay, so the second part of this question is considering, again, we've got the moving observer. Let me just check the question. So this time, the light, that's right, this time uy, this time the velocity of light, the light is travelling along the y-axis. So this time what we have is that ux is equal to 0, uy is equal to c, and uz is equal to 0. Okay. Okay, so the light is travelling along, so the stationary observer sees the light travelling along the y-axis. The other observer is again travelling along the x-axis at v, and what we generally want to know is the values of ux prime, uy prime, and uz prime as measured by the observer moving at v relative to them. Okay, so that's what we're trying to find out. So if we go and have a again look at the expressions, we saw them earlier: ux prime, uy prime, and uz prime. Ux prime is going to equal ux minus v, so it's going to be 0 minus v divided by 1 minus ux is again 0 times v over c squared. So ux prime is going to basically be minus v. We then want to look at uy prime. Uy prime is going to equal uy, and that's equal to c, divided by gamma times 1 minus ux. We said that's 0. 0v over c squared. So this here, uy prime, ends up being c divided by gamma. Yep, I think it's c divided by gamma. And finally, uz prime is equal to uy divided by these. Sorry, uz is simply 0, so that's 0. So we have these, ux is that, uy is that, uz is that. Now that doesn't immediately look like the light is still moving at the speed of light. In fact, it's got an x component, a y component, but no z component. But is the overall speed equal to the speed of light? Well, it better be. Let's just check. So u prime squared is going to equal ux prime squared plus uy prime squared plus uz prime squared. Okay, that's the overall speed the light's travelling. Let's just square these terms and add them up. So minus v squared, we can do that, is v squared. Plus here, this term here is c squared divided by gamma squared. So c squared, now gamma squared, if we remember, is gamma is 1 over the square root of 1 minus v squared over c squared. So the square of that, this is simply going to end up being 1 minus v squared over c squared. That's that term. Oh yeah, that's divided by, so gamma is this. Gamma squared is this, 1 minus v squared over c squared to the minus 1. So we've got that in there, that's that. And then plus our uz squared term, which is going to be 0. Okay, so we've just about run out of space, but we can then last a little bit, we can just about squeeze in. U prime squared is therefore equal to v squared plus, and we can see this is c squared, so this is this thing here to the minus 1. So we multiply by that, so it's going to be c squared. It's going to be 1 minus v squared over c squared times c squared. Okay, it's going to be v squared. But let's just multiply the c squared through v squared. C squared times 1. And we've got minus v squared over c squared times c squared is a minus v squared. And hey presto, the v squareds cancel. This again gives us c squared. So, as we found previously, the light is indeed travelling at the speed of light. What happened this time? The question asks you what has changed about the light, and what it is the angle it's travelling at. Okay, so before it was travelling to the stationary observer, it was travelling simply along the y-axis. Okay, so simply observe the light travelling along the y-axis like that. In the moving frame, okay, which is again moving this way at speed v, the observer has seen it's actually got an x component of minus v and a y component. So the moving observer no longer observes the light moving simply along y, involves it moving backwards in x and positive in y. So the moving observer, as you'd imagine, sees the light moving in that kind of direction.